Are you ready? Because the 4090 is here. Hey everybody, this is Chris with Overclockersclub. By now you've seen all of the unboxing videos of the RTX 4090. This stuff is everywhere out there. Today we actually are going to go into more details on the card itself, but there is so much to cover. I'm going to do this in at least 2, maybe even 3 parts. Today we'll cover some of the technical aspects of it, what makes the 4090 the beast that it is, the DLSS, the latest technology there. Then we'll go over content creation, folding at home, which is something I enjoy, and then we'll look at gaming performance. Now you may notice the card is sort of sitting up there a little higher than normal off the motherboard, and there's a reason for that, and we'll go into that a little later. But when you get a card like this that's released, and the expectations are, of course, anytime there's a new series out, but the expectations are that it's bigger, faster, hopefully less expensive, but that's not usually the case, more efficient, things like that. So with this card, you've got a lot of new technology. You've got DLSS, of course, and the artificial intelligence, the AI that goes along with it. All of that combined does more than what the hardware alone can do, and that's what we'll talk about. And I already kind of went over the card itself, the exterior features in the unboxing, so and really by now you should have a pretty good idea what the card looks like, but we'll take another quick look here. I've got it supported here at the back, so it's nice and level, but you don't get a real appreciation for the size of this card until it's in front of you, and it's just massive and it's very heavy. You're really going to have to be careful. The case that you put this in, the motherboard that you secure it to, you really want to make sure that this card is really locked down because it is very heavy. Now it does have, and I haven't been able to find any real information, but then again I haven't looked real hard. On the back there is this little door, and it's just held on magnetically, but it's got 2 tapped holes, and I believe these are for some sort of a mounting bracket, or at least I don't know why you couldn't use them for that. But that's what this little door here is, and it covers up real nicely so it sort of blends in. But you've got a 120 millimeter exhaust fan on this side. It's almost like a push-pull, but it sort of moves air through the card, and this is the, I guess you'd call it the inlet side. They are 120 millimeter fans. It's a little hard to see, but I can see very clearly. Yeah, you can see through there. You can see how open that is for the heat pipes for the cooler, and so that means the PC board for this card, everything is happening here on this end, and the whole basically back half of the card is cooler. And I'm not sure, it looks like, yeah, I don't see any heat pipes up here. Now as far as the end of the card here, we've got 3 display ports and 1 HDMI. Again, some pretty good size venting here. We've got 3 slots, and here's your power connector on top. This is the new style that everyone is slowly migrating towards, and this is lighted here. There is a little lighted trim section, and the GeForce text there does light up. Now I do not have a 3090 here for size comparison. This one is a 3070 Ti, and I'll sort of position it like that so you sort of get an idea for the size difference there. The 4090 just really dwarfs the 3070 there, and the 3070 is a pretty heavy card, but the 4090 is quite a bit heavier. So I can spin this around a little so you can sort of see the size difference there between these two. The joke I made during the unboxing is that you could put a license plate on this thing and take your family for a vacation, and it's like an RV. And again, the size here, when you put it on your motherboard, it's like strapping a refrigerator to your motherboard. It's big and heavy, so you definitely want to be careful. And the only reason I say be careful is once you get a card like this in your case and you go moving your case around, you have to be very, very careful that you don't drop your case, because there's a lot of mass there that can do bad things to your motherboard. Okay, so I'll go ahead and get this mounted on the motherboard. And we are ready to fire up the 4090 for the first time. We've got our display port connected. We've got our special power adapter all connected. And if you're thinking about an upgrade for your power supply, now might be a good time to do it. All right, so let's hit the power button and see what happens. All right, so that lights up. That's nice. Let's see if there's anything on the other side. A little bit of a light there around sort of the trim on the fan. That's very nice. And there we go, all fired up. And of course, anytime you get a new graphics card, what do? You need to go and get the latest NVIDIA driver. And I always use NVIDIA GeForce Experience. It's fast, easy, and convenient. Now, this next slide here, this actually is from NVIDIA, and this shows you some information about the power supply and the power requirements. A lot of people have questions about that. What sort of power does this 4090 draw? And this next page right here, this is actually from an NVIDIA forum, and I'll post a link to it in the description, but this answers a lot of questions, and you're getting your information direct from NVIDIA, so you don't have to worry about people posting opinion. This is coming directly from NVIDIA. Good information to know. And here are the details for my test system. I'm using a Viotech GNV34DBE monitor. It's 3440 by 1440p on the resolution, and it's capable of 144 Hertz on the refresh rate. The motherboard is an MSI Z690 Carbon Wi-Fi. This is the DDR5 version. The solid state drive, my main drive, is an SK Hynix Gold P31 2TB CPU, Intel Core i7-12700KF. The cooler is a Fractal Design Celsius S36. The GPU, of course, is the NVIDIA RTX 4090. Memory, I've got 32 gigabytes of Kingston Fury Beast, and the power supply is a Fractal Design Ion Plus 2, 860 watts. And the next little page or slide here, it's a comparison of the 3090 Ti to the 4090, and as you sort of start at the top and work your way down, you can see some of the differences are fairly minor and others are quite profound. And let's see what really sticks out. The texturing processor, or the texture processing clusters, 42 versus 64. Streaming multiprocessors, 84 versus 128. Significant jump on the CUDA cores, as well as the tensor cores. The RT cores also pretty good jump. Texture units, same thing. ROPs, boost clock, there's a pretty significant jump on the boost clock. Memory clock is about the same. L2 cache, there's a bump, significant bump in that. Actually, that's a huge bump. Total video memory is the same between the two. Memory interface and bandwidth are also the same. We got a pretty good jump here on the texture rate. And let's see, moving down to the transistor count. 28.3 billion transistors versus 76.3 billion. That's a lot of transistors. Form factor is the same. Looks like the power requirements are showing to be the same, and a slight difference on the maximum temperature. So if the 3090 really opened the door to 8K gaming, then the 4090 has taken that door and made it much larger. Now, if you can remember back, there was a time when 1080p was about as good as you could get, and with 8K gaming now, well, you've got 16 times as many pixels as you did with 1080p, and again, it takes a lot of horsepower to drive that many pixels. And that's what the 4090 can do with the new streaming multiprocessors. You get up to 2 times the performance and even better power efficiency. You've got the 4th generation tensor cores. You get up to 2 times the AI performance, and then the 3rd generation RT cores, they give you up to 2 times the ray tracing performance. And all of that translates into more FPS, more frames per second. You can see the massive increase here across the board here when you've got DLSS enabled. So how does all this work? Well, here's sort of a rundown on how DLSS works. So there are three main components, and the first one is the AI super resolution. The second one is the AI frame generation. And what the frame generation does is it creates additional frames, and this boosts performance. Now the third component is the NVIDIA Reflex. And the NVIDIA Reflex synchronizes the CPU and the GPU, with the goal being to reduce latency. In addition to the three software components, there are also three hardware components, and all of these come together so that DLSS can basically work its magic. The fourth generation tensor cores are responsible for the frame generation and the super resolution. The optical flow accelerator is a necessary part of the frame generation. And the final component is the NVIDIA supercomputer, which basically runs to train the DLSS models. So like I said, all of this comes together to produce an immersive experience, the best that DLSS 3 can deliver. Now, I've seen where some people were upset or a little disappointed that the display ports are only 1.4, the HDMI is 2.1. But the expectation was that with a monster card like this, surely we would see 2.0 on the display port, and we don't. We see 1.4. So what you have to keep in mind is these cards, and really any electrical component or device, motherboards, anything like that, these are in development long before you ever see anything leaked about them. My guess is the 5090 is probably already in development as we speak. I don't know that for a fact, I'm just guessing. But anyway, where I'm going with that is at the time this is in development, you have to lock down certain functions and features based on what's available. So perhaps, and again I'm just speculating, the DisplayPort 2.0 may not have been available at the time this card was being developed, so they have to go with what is available and then lock that feature down, even though it may not be what everybody wanted. It's what we have now. So who knows? We may see it here on the next iteration. Now you may have noticed the graphics card there looks a little funny. It's sort of sitting up high on the motherboard, and there's a reason for that. If you look down there, there's a special riser that plugs into the PCIe slot, and that's provided by NVIDIA. You can see a little green LED and a power connector, or some sort of a connector there. And that goes over here to this PC board. This is the NVIDIA PCAT, supplied by NVIDIA. That stands for Power Capture Analysis Tool. What this does is it looks at the power coming in from your power supply right here, and it goes out up to the graphics card. But we're looking at real-time measurement of the measurements of the wattage or the power being used by this card. Of course, it's also monitoring whatever power is coming through that riser also. But it sits up high enough off the motherboard. It's already a very large, heavy card. And when you're sitting on a riser like that, and I don't really have a frame on my test bench, so I had to support the card, so I had to rig something up temporarily. Again, this is just for the power draw on the card testing, and I'll get the card back on the motherboard. It's just temporary, but that's what this is. Very, very useful tool. Now, some people will be curious as to what the fans sound like. They are 120 millimeter fans, and there are two of them. So at idle here, we're running at about 30%. They're quiet. You can't hear them unless you put your ear right up against the side here, and then you can just hear, you know, a light hum of a fan. But if we crank it up here to, let's just say 60%. Actually, let's look at the decibel meter here. So at idle, we're around 45, 46 decibels, roughly 3 feet away. And if we crank this up to about 67% on the speed, let's see here, I'm using MSI Afterburner. So we're about 67%. So it goes up a little. You can hear them, but they're not bad at all. They're really pretty quiet. And let's go ahead and crank this all the way up to 100%. Now let's So normally these things probably aren't going to be running at 100%, and you're probably going to have this in a case. So this is like worst case scenario here. Actually, I have to apply it before they come down. There we go. So can you hear them? Sure, when they're cranked all the way up, 220 millimeter fans, yeah, they're going to make a little bit of noise. But normally, and again, your card's usually going to be in a case. I don't think it's a problem. All right, we'll take a quick look at the card thermally with the infrared camera and give it a moment. You can sort of see the heat pipes there showing up now. It's at idle, sort of like a 0 RPM mode. So when there's no load on it, it just sort of sits there and runs quietly in the background, and the fans don't do anything. So you can see again, there's no real load on it. So now I'll go ahead and put a little load on it. All right, so I just fired up Time Spy from 3D Mark, and the fans came on almost immediately. So that tells me that there's definitely a load. There's the back side of the card. You can definitely see the warm spots there. And right in there, there's something going on. It's a little warm. Right in the middle. That's actually the back of the fan motor, now that I think of it. If we look at this side, that would make sense. Around, look at this. So things get a little warmer. So we'll come back toward the end of the test here and look at it. Well, the fans seem to be holding it at about 62 degrees Celsius during this particular stress test, which the fan noise is almost nothing at that rate. And the temperatures haven't really changed a whole lot. So anyway, this is just what the thermal camera shows. It doesn't really tell you anything really useful about the card. It's just interesting. All right, so I'm going to try and see if I can figure out the wattage that is used. So I'll run the NVIDIA DLSS Feature test. And let's see. I think I'll go ahead and do the overlay from GeForce Experience. Now, I've already done the performance tuning. So when this thing gets rolling, there's your clock speed right now and the power usage according to the GeForce Experience. Takes us a moment to get rolling. But I was hoping to be able to plot the wattage here using the PCAT software, but for whatever reason it is not communicating with the module. I don't know if I don't have the right version or there's a driver issue, but right now all I can see is the display output. And let's see, it should be getting ready to fire up here. And then we'll see what the wattage is showing. Okay, so now we're rolling, and I did the performance tuning earlier, and that's a pretty good clock speed there on the GPU. And we're in the 420, 433, and let's see what the PCAT over here is showing. It's kind of all over the place. Of course, this is probably, you know, a real-time versus this may be more of an average. But it does sort of give you some frame of reference. So the peak so far I think I've seen is 433 watts. Again, assuming this is anywhere close to accurate. Because since I can't plot my data here, it's really hard to make sense of what I'm seeing there, because I see 470, 480 as it bounces around. And now I'm using the stress test for the GPU from A to 64, and I'm seeing just under 400 watts there. I haven't seen it hit the 400 mark yet. And then the display over here is showing just a little over 400. It doesn't seem to vary as much. For what that's worth. So again, that should give you some kind of an idea of the power usage. Now we'll be doing some testing with DaVinci Resolve. If you've never used DaVinci Resolve, it is amazing software for generating videos. I've been using it for the last couple of years, and it's amazing. And they do have a free version that has some limitations, but it is still awesome. So we have some testing that's already been done. I'm going to see if I get the same results. And really, this is just testing the encoding performance using the 4090. So the results here for this particular test, I believe this comes in at 14 seconds to render this. So we'll go ahead and render it. And you can see here it's moving pretty quickly through this clip. And it is almost done. And I believe the test result that I should get, this is 4K 30 H.265 on the encoding, and I've got 14 seconds, and the previous testing there, the sample encoding performance for the 4090 is 14 seconds, so I'm the exact same result. And you can see here the 3090 did it in 33 seconds. I don't have a 3090, but this is just to compare, and I did get it in 14 seconds, which is what it shows for the 4090. Okay, so now we'll go to the next test. So the second clip here is, the first one was 4K, this is an 8K, and so it will take longer. Now the sample from previous testing shows 47 seconds. I ran this a minute ago and it got a little over a minute. I ran it again and it was down to 52 seconds, so there's only a 5-second differential. And this is almost done. Let's see what we get. Yeah, 52 seconds again. So for whatever reason, this is taking just a little bit longer than what the test sample shows. So now we'll move over to the AV1. We'll run it in 4K and 4K and 8K and see what kind of results we get there. So the first test here is 4K using the 4K file. So let me zoom in a little more. And I believe this one should only take 14 seconds. So this should be pretty quickly. All right, so we add to the render queue, replace, and render it, and let's see. Oh yeah, it's moving along at a pretty good rate. And again, this is the 4K, and the next test, the last test here, will be using the AV1 codec with an 8K sample. And let's see. Yep, 14 seconds over there. Move that over a bit. 14 seconds in the corner. So that's exactly what the test sample showed. So now let's switch this over to 8K. And I think my settings over here, let's see. Check out my reference. That's 4K. We come down here to 8K. Okay, 30. So the difference is I need to change the resolution. Okay, so we're already there. 7680 by 4320, 8K Ultra. And everything else I think is the same. Constant bit rate. Yeah, that looks good. So we will go ahead and render. or I should say add to render queue, and there we go. Now this will take a little longer since it is 8K. So I ran the 8K test twice, and I got around 67 seconds both times, and the initial testing data was 50 seconds, so it's a little slower. I guess you can attribute that to your mileage will vary, maybe. I'm not sure. The other two tests, I nailed it. I got it exactly with what they showed. So, like I said, still awesome performance. You're not going to find that anywhere else. So now we'll run some testing with 3D Mark, and this will go through basically two tests. The first one is with DLSS 3 disabled, and then it runs on into the next test, which is with DLSS 3 enabled. So we'll see the performance difference, the image quality, and the frame rate. And it takes it a moment here to load. But once it gets rolling, and I think this is one of those situations where you know, the quality that you're looking at, you're pretty happy with until you see how good it can be. So like right now, our FPS, we are 50, 48, 49, 50, 55. And the image quality here looks really nice. Now this is a 3440 by 1440, 34-inch wide Viotech monitor. 144 hertz is what it can be cranked up to the maximum. So I'm looking here. What I'm looking for is fine details to see when the DLSS 3 is enabled. So right now it's off. DLSS is off. And what I look for are some of the fine details, the reflections, things like that. They're, you know, they look very subtle initially. And like I said, you don't realize, I won't say it's bad, you don't realize how bad it is, but you don't realize how good it can be is really the best way to say it. And again, we're staying right around 50 to mid 50s on the frames per second. And we'll let this finish, and then as soon as it goes back into DLSS on, I'll start recording again, because it's kind of boring to just sit here and watch the test run. Okay, here comes the DLSS enabled, second part of the test, and we'll be looking at frame rate and image quality. And right off the bat, we're in the 175 frames per second, so that's huge. I saw it jump over 200 there briefly. And then DLSS is on. And I can already see some differences in the clarity. The generation of the small details here is much more, wow, that's something much more intense. Yeah, I can see the way the reflections are generated here. There is a difference. And we're down into, well, it's coming back up closer to 200 on the frames per second. Yeah, I can definitely see some noticeable differences in the way that frames are generated here. Much clearer, cleaner, sharper. And I'm still between 150 and 200 frames per second. Yeah, you can really see it. That's impressive. And I think this is the end. Yep. Wow. And looking at the details here, with the DLSS off, we're at around 56 frames per second. With DLSS on, 185. That's a huge, huge improvement. Let's look at some of the other details. Okay, so we're not too concerned with that. Let's go down to the next. Here we go. Okay, so the graph here, the orange line here is frames per second. So you can see on the second test with DLSS enabled, there's your big jump on your frames per second. The blue line here is temperature. It's sort of crept up a little on the first test. The second test, it actually looks like it leveled off and actually dropped a little and held. Everything else here is pretty consistent. So I think that's a pretty clear indication that the DLSS is pretty impressive. Now, one thing I want to talk about, and this is really important to me, in addition to gaming performance, I do something called protein folding, or folding at home. You can go to foldingathome.org. It's actually spelled out, folding and then at home, H-O-M-E, .org. But anyway, you can go to that website. If you're not familiar with what protein folding is, basically when your cells are synthesizing proteins, they build them like a three-dimensional Tinker toy. And as the different layers and sections are assembled basically in your cell, they fold over and they fold into different shapes. And if there's an error in that building or folding process, you can get all kinds of diseases and sicknesses and illnesses. And folding at home basically uses your computer, basically your GPU. You can use your CPU, but the GPU is really where you get all the horsepower. And you're basically crunching numbers for very large simulations that used to take a very long period of time. You can do these things in minutes to hours. And the data then is uploaded to the university and you get points. The points aren't worth anything. You can compete with different teams. And I'll show you here what I got. And this is what a lot of people are interested in who fold. So when I first fired this up, I got, you can see right there, 15,248,627 points. In fact, let me zoom in there so you can actually see that. 15 million points. You can see we're using the 4090, so the 4090, the 8102 core, is in the folding at home GPU whitelist. So as soon as you get a 4090, it should start folding. And this shows how many minutes are it's into the folding cycle. But like I said, I was surprised. Over 15 million points. And then I did another project right after that, and I got, let's see, I was surprised again. If you look right here, a little over 26 million. Now that's the highest I've seen so far. It's all over the Mac between 8 million, 12 million, 15 million, but the highest I've seen is a little over 26 million points, and again using the RTX 4090 that is now in the GPU whitelist. And like I said, you can fold with your CPU on your computer, but anymore, even higher end CPUs just do not have the performance that a good GPU will. And you can fold with more than one GPU, you can fold with more than one computer. It does produce a lot of heat because your GPU is being stressed, but like I said, 26 million points is the top that I've seen so far. And talking about heat, the GPU here on the 4090, the card seems to hold right at around 50, 51, 52 C, depending upon the room temperature. And it's between 24 and 25 Celsius here in the room. And the fans are 61%, so they're reasonably quiet. So I know a lot of times with the older cards, or previous generations, you have to really crank the fans up and they make a fair amount of noise to keep them cool. But this one seems to make pretty good use of the power. Well, so far this card has been able to handle everything I've been able to throw at it. And I'm still actually getting comfortable with it and learning its capabilities. But it's amazing, I tell you what, there's a lot of horsepower here. So what else can I say about the RTX 4090? It's an amazing card with an amazing price tag, but that's to be expected because it's a top tier card. And this isn't for the average Joe who just needs to grab a quick video card. So yeah, you know, $1,600 will get you the top of the line card. And as this matures, we'll see more and more games that become available that support the technology that really takes advantage of this card. And as 8K gaming slowly creeps into the equation too, this card will become more and more relevant. So that pretty much wraps up part 1 here of this review. There will be part 2 following shortly. It will cover gaming performance, things like that. So make sure you check back for part 2. This is Chris with Overclockers Club. Thanks for watching, and of course, don't forget to subscribe.